morning students. Our next topic is mathematical induction. Before going to learning about mathematical induction, we just remember some formulas already we discussed in 10th class arithmetic progression, geometric progressions. Okay, so just remember the formulas here. If for suppose a plus d, a plus 2d and so on form an AP. Actually we know common difference is d here for every two terms, consecutive terms, common difference is d. So then that series is called arithmetic progression. So here nth term is formula Tn is equal to a plus n minus 1 into d. Sum of n terms is Sn is equal to n by 2 into 2a plus n minus 1 into d. If you know the last term of this arithmetic progression, then you can use this formula to find the sum of n terms, that is n by 2 into a plus l also. Okay. Here a is equal to first term, d is equal to common difference, l is equal to last term. And if a square, ar square and so on form a GP, then here nth term is Tn is equal to a into r power n minus 1. Okay. Sum of n terms is Sn is equal to a into r power n minus 1 by r minus 1. In an infinite GP, sum of infinite terms is S infinity is equal to a by 1 minus r. Infinite terms, sum of infinite terms possible only when mod r is less than 1. That means r common ratio will be lies in between minus 1 to plus 1. Then only we can use this formula. Otherwise, sum of infinite terms we cannot find out. Okay. Here a is equal to first term, r is equal to common ratio. Okay. So next one. A plus d into r plus a plus 2d into r square plus and so on plus a plus n minus 1 into d into r power n minus 1. So till now we didn't discuss about this series. Actually like this series, whenever you observe a plus d, a plus 2d and so on a plus n minus 1 into d, all these are in AP, and a here r square and so on r power n minus 1, that is considered. So ar square, like that. We have r square, r power n minus 1 are the factors of these terms. So then whenever if you observe the series in this way, so like this series is called arithmetic geometric progression. Form an arithmetic AGP, arithmetic geometric progression. Here just remember these formulas, very important. Sometimes in IPE method, these formulas may be useful to us. Okay, for IPE problems, for objective maximum no need, but sometimes if necessary we can use. Okay, so here nth term Tn is equal to a plus n minus 1 into d into r power n minus 1. Easily we can remember a plus n minus 1 into d is nothing but in AP some nth term, and a into r power n minus 1 is in GP nth term. So without writing a, just to write r power n minus 1 with this a plus n minus 1 into d. This is for nth term in AGP. Sum of n terms Sn is equal to a by 1 minus r plus dr into 1 minus r power n minus 1 by 1 minus r whole square minus a plus n minus 1 into d into r power n by 1 minus r. Just remember this formula also. Sum of infinite terms S infinity. This is also for formula AGP. So here also mod r should be less than 1. That means minus 1 to plus 1. R should be lies in. Okay. S infinity is equal to a by 1 minus r plus dr by 1 minus r whole square. Okay. These formulas we just remember to find nth term in the given series. Okay. So where we need to use, I will explain later. Next one. So these formulas are also very useful. So already we know 1 plus 2 plus 3 plus and so on plus n is equal to n into n plus 1 by 2. 1 square plus 2 square plus 3 square plus and so on plus n square is equal to n into n plus 1 into 2n plus 1 by 6. 1 cube plus 2 cube plus 3 cube plus and so on plus n cube is equal to n square into n plus 1 whole square by 4. Okay, just remember all these formulas. Next, going to define principle of finite mathematical induction. So what is principle of finite mathematical induction? Why you are using this finite mathematical induction means just you go for this one. Actually I gave these formulas without proof. 1 plus 2 plus 3 plus up to n is equal to n into n plus 1 by 2, and 1 square plus 2 square plus 3 square plus up to plus n square is equal to n into n plus 1 into 2n plus 1 by 6, and 1 cube plus 2 cube plus 3 cube. All these formulas, How can you prove? Actually, like this problems, generally you take, this is left side, this is right side. First you take first one you take here. For n is equal to 1, if both are equal, just you go for 1 into 1 plus 1 by 2. So what is this? 2 by 2. 2 by 2 is nothing but 1. So both are equal. So next, for n is equal to 2 means take up to 2. Sum of n terms is equal to n into n plus 1 by 2. Sum of n terms. Here I are going to take sum of 2 terms. Whenever sum of 2 terms, you take n is equal to 2. Sum of 3 terms up to 3, you take n is equal to 3. If both are balanced, both LHS and RHS, then it is proof. Okay, take for n is equal to 2. What it is? 1 plus 2. Okay, for n is equal to 2. LHS is 1 plus 2, that is equal to 3. Here for n is equal to 2, what it is? 2 into 2 plus 1 by 2. This is equal to 2 get cancelled, this is also 3. So for n is equal to 3, for n is equal to 4, for n is equal to 5, for n is equal to 6, we have to check for up to n. Both LHS and RHS are equal, then this statement is true. Is it possible on the paper checking for n is equal to 1 for all natural numbers? That means n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 6. Up to how much we have to check it out? Is there any ending number? No. Up to n. How can you go up to n? It is not possible. So, like these problems to prove, we have to use math per induction. Our mathematicians, they worked on like these problems more times and give a conclusion to do in short form. Okay, now we are going to prove, now we are going to discuss that short form, that is called the mathematical induction. So principle of finite mathematical induction. Let S of n be the given mathematical statement. What is the given mathematical statement? Like this. So here, this is the one statement, this is one statement, this is one statement. If you want to say it is true or false, we have to follow following steps. So let S of n be the given mathematical statement to be proved for all n belongs to n. Here n is, capital N is natural numbers. So for all natural numbers, if you want to say given statement is true, first we have to prove basic step, that is S of n is verified to be true for n is equal to 1. So first we have to prove for n is equal to 1 on both sides. For n is equal to 1, so it is true, it is 1 here, LHS 1, RHS also 1. Okay, you have to verify. So verified. So which is the least element of n? N means natural number. Okay, next induction step. This is important step. Assume that S of k is true for some k. Assumption means no need to prove, just we have to assume. So already that is we have to understand that is proved only for n is equal to k. Okay, that one you have to assume, don't prove. Assume that S of k is true for some k, then prove that S of k plus 1 is true. If you assume this one, S of k is true for some k, that means S of n is true for n is equal to k. This meaning S of k is true means S of n is true for n is equal to k. That is we have to assume. Then we have to prove. This is also proof. How you have verified for n is equal to 1, same like that we have to verify for n is equal to k plus 1. So then prove that S of k plus 1 is true. Hence S of n is true for all n belongs to n. So if you take this step and assume this step, and if you prove this step, then no need to check for all n belongs to n. That means n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, up to n. No need to check. Just for n is equal to 1, we have to verify. Second step, you have to assume for n is equal to k. Third step, you have to prove that n is equal to k plus 1. For n is equal to k plus 1, proving means we have to, for suppose this is n of n, this is the statement, we have to take up to k plus 1 terms on RHS, on LHS. That means how to take 1 plus 2 plus 3 plus up to k plus 1 means we have to take up to k plus 1 is n is k plus 1. N is equal to k plus 1. Like that we have to take. And what we have to prove? In the place of n in RHS, if you get k plus 1, that means k plus 1. This n we can write as k plus 1 plus 1. By any n terms are there? No, by 2. If you get like this, okay, so k plus 1 into k plus 1 plus 1 by 2. If you take like this, so 1 plus 2 plus 3 plus k plus k, because of after k we get k plus 1. Okay, after k we get k plus 1 means we are considering n is equal to k plus 1 on LHS. If you prove k plus 1 into k plus 1 plus 1 by 2 like this, okay, in the place of n k plus 1 k plus 1 plus 1 by 2, then we can say s of n is true for n is equal to k plus 1. This one we have to prove. For n is equal to 1 we have to prove, but for n is equal to k we have to assume. Okay, n is equal to k, assume means 1 plus 2 plus 3 plus up to plus k is equal to k into k plus 1 by 2. Just replace n by k. So that is for n is equal to k. Okay, if you prove like that, so no need to check for all natural numbers. Okay, directly we can say, if you take n is equal to 1 to prove, and assume for n is equal to k and prove n is equal to k plus 1, then we can give a conclusion that the statement is true by using principle of mathematical induction. Okay, so this process is called the finite mathematical induction. Okay, second one, principle of complete mathematical induction. This is finite mathematical induction, this is complete mathematical induction. S of n is verified to be true for n is equal to 1. Same like in this complete mathematical induction also, S of n is verified to be for n is equal to 1, which is the least element of n. Same, first steps are equal. Second one is assume that S of 2, S of 3, S of 4 and so on up to S of k. Assumption, same like here, how you assume for n is equal to k, S of k. Here we have to assume all these things, S of 2, S of 3, S of 4, and that means n is equal to 2, n is equal to 3, n is equal to 4, up to n is equal to k, we have to assume. Okay, so are true, assume that are true, then prove that S of k plus 1 is true. Here also how you prove S of k plus 1 is true, same here also. But here only we are assumption S of k is true. Here we have to assume all these things, S of 2, S of 3, S of 4, all of them are true. Okay, hence the statement S of n is true for n belongs to n. This process is called the complete mathematical induction. So to prove these problems, which process, which method we have to use, either finite mathematical induction or complete mathematical induction. See here, I am giving the note. The principle of mathematical induction is a method of proof of a statement. Method of proof of just that is a method of proof of a statement. Principle mathematical induction is that is there is no another meaning. Just that is nothing but method of proof of a statement. Here I am giving second step. This is important. We often use the finite mathematical induction. Hence or otherwise specified the mathematical induction is the finite mathematical induction. That means if he mentioned particularly you should go for complete mathematical induction only, we have to go for complete mathematical induction. Otherwise we have to use always finite mathematical induction only. Finite mathematical induction means step 1 is verified to n is equal to 1, assumption for n is equal to k, and proof for n is equal to k plus 1. So based on this I will explain some problems in next video.